A female engineer aged 22 to 25 checked the electronic display panel, while workers aged 22 to 25 moved slowly around the landing gear.
Modern aircraft appear powerful and stable from the outside, yet deep inside they are built upon a great fear.
Many passengers believe that the more advanced technology becomes, the more an aircraft can rely entirely on a single central brain. In the world of modern aviation, danger does not begin with a major failure, but often starts at the moment humans trust too much. For instance, the male engineer bent down to inspect a tiny pressure sensor hidden deep inside the electronic compartment, and he understood that I'm seeing a persistent error on the primary signal.
Rerouting to the cross-check systems now. We need to confirm this anomaly.
The clean and disciplined atmosphere of the maintenance hangar made every movement slow but precise. A larger question began to emerge. If aircraft had become so advanced, then why did they still never dare to trust a single system? This was not only a story about engineering, but also a story about how aviation views failure as something certain to happen at some point in time. Under normal operating conditions, a modern aircraft always has multiple layers of systems running in parallel, even though passengers almost never realize it while sitting quietly inside the passenger cabin. The engineer checked the primary electrical system and then continued opening the backup power control panel, as if caring for two hearts at the same time.
The female engineer monitored data from multiple different displays while every number was continuously compared to ensure that no abnormal discrepancy was silently appearing. A modern aircraft often has multiple flight computers processing the same task together, and each computer monitors the others instead of allowing.
Even the sensors measuring airflow speed outside the aircraft body usually exist in separate clusters, so that if one device freezes or produces false data, the young workers inside the maintenance hangar removed each electrical cable cluster and inspected every small connection, because they
industries. In many other industries, one powerful system may be considered safe enough, but aircraft operate in an
When an aircraft leaves the ground, every system decision must be accurate from the very first moment, because the sky has no roadside where one can stop and check again like on the ground.
The male engineer walked along the matte gray metallic aircraft body and stopped in front of the central electronic compartment, where dozens.
That is the normal condition of modern aviation, where everything operates stably, precisely, because no one is ever allowed to trust a single source completely. But the very existence of so many backup systems has led many people to question whether the aviation industry may be too fearful of the possibility of failure.
If modern technology is already intelligent enough, then why do engineers still have to build so many expensive and complicated layers of protection inside the same aircraft?
The female engineer looked again at the simulated sensor failure data and realized that the greatest problem of technology does not lie in the moment it fails. A single system can produce extremely convincing results, and that very convincing appearance sometimes becomes the most dangerous thing in aviation. There are situations where a speed sensor sends false data that causes the flight computer to misunderstand the condition of the aircraft. Even if other systems did not exist to challenge that data, then both the pilots and the computers could be pulled into a wrong decision before anyone realized it. The young workers continued replacing a small signal cable, even though it was still functioning, because in aviation, risk is always handled before it becomes a real failure. The major contradiction of modern technology began to reveal itself. The more intelligent a system becomes, the most dangerous thing was not a weak system, but a system so powerful that people stopped checking it. Modern aircraft do not fear that one device may fail. They fear the moment when everyone believes that device can never fail. That was the moment when the core reason behind the entire philosophy of modern aviation design began to be explained more clearly.
The aviation industry is built upon the assumption that any system, no matter how advanced, will eventually fail, because
the Middle Eastern female engineer opened the cross-check panel between multiple flight computers and saw how each system continuously compared data with the others.
Aircraft do not trust a single system, because aviation understands that the most dangerous failures are often not the obvious ones.
If a single system fails, there will be no one left to challenge it, and in flight that means there is no final protective layer remaining between stability and catastrophe. The male engineer continued inspecting the backup power sources and understood that each layer of redundancy exists, not because modern aircraft often have multiple power lines, multiple computers, multiple control systems, and multiple sensors. Even pilots are not considered the only decision-making source because automatic warning systems and cross-check mechanisms always operate in parallel to detect discrepancies.
The workers inside the maintenance hangar replaced each small component with patience that seemed endlessly repetitive.
What makes aviation unique is that it does not wait for accidents to happen before fixing problems, but always assumes that
Instance. That is why modern aircraft are never allowed to place absolute trust in a single source of data, a single electronic brain, or stored. Compared to many other technological industries, aviation may appear slower to change, but in reality, that is the price paid to birds. A phone can restart after failure, but an aircraft flying tens of thousands of feet above the ground does not have such a simple opportunity.
The female engineer looked through the hangar window toward the quiet runway and understood that every layer of backup systems
If only a single system existed, then the entire flight would depend completely on that system never making even one mistake throughout millions of hours of operation.
But the aviation industry is not built upon the hope that bad things will never happen. It is built upon the assumption that bad things will eventually happen.
Tollitwood. The African-American male engineer continued comparing data between multiple displays and realized that true reliability does not lie in the
Millions even injuries. Modern aircraft, therefore, do not only have primary systems, but also backup systems, cross-check mechanisms, and
The young workers cleaned each tiny electrical connector as if they were protecting a principle far greater than a simple metallic component hidden inside the aircraft body. That principle is that aviation safety does not come from absolute perfection, but from the ability to accept that everything can fail. Modern aircraft never trust a single system, because absolute trust is always the most dangerous thing inside any complex system created by humans.
The male engineer walked slowly along the aircraft wing and understood that the entire aviation industry exists today not because it is perfect. The young workers continued their tasks inside the clean and quiet environment, as if every small movement they made was...
In the end, the answer to the title of this video became completely clear. Modern aircraft never trust a single system.
These backup layers do not exist to prove that technology is weak, but to prove that aviation is mature enough never to place human lives into a single belief. In the world of aircraft, weighing tens of tons flying across the sky, safety does not begin with absolute allegiance. In the world of aircraft weighing tens of tons flying across the sky, safety does not begin with absolute trust.